I'm Kristie, and I work at Pluralsight on the video team. I started out doing visual design and then moved into front-end development, and currently I'm doing full stack with React and Node. If you have any questions we don't get to afterwards, hit me up on Twitter or stop by the Pluralsight booth after this, and I'll be hanging out there. I think there's a break. Before we get started, I just want to do a quick survey. Can I get a show of hands if you've ever been using a website and seen some weird error message in the UI, maybe like this one that says payment method type not found, undefined, or maybe someone's entire stack trace, or even just the nice classic white page that says internal server error. And how many of you have ever had your product break in production because a dependency blew up? Okay, cool. Well, clearly this is a thing that we can work on, because even if we're building these highly available fault-tolerant applications that run on Kubernetes with auto-scaling and automated tests that run before our CI/CD builds, things still break sometimes. No matter how many precautions we take with our infrastructure and our testing and processes, things are still going to fail. And the bigger your system and the more pieces it has, the greater the chance that at any given time, something is not going to be working perfectly. A lot of times we just test against the requirements we're given, and if we make an app that does the things it's supposed to do and looks the way it's supposed to look, even in IE, we think we're good and just move on to something else. How often does your PM write user stories around what happens when a dependency goes down? Probably not until it's gone down in prod and drawn enough attention that they're hearing about it, right? So that's why it's important that we as developers start the conversation around what happens when this breaks, and then design our software with those plans in mind. You don't have to be using all the latest and greatest infrastructure and engineering practices just to stop and think about how you're handling things like failures and latency and unexpected input. So my goal today is just to give you some ideas about how you might want to approach some of these problems, and to encourage you to think through your sad past early and talk them over with your teams. So there are a lot of components to resiliency, and they're all super important. We've got auto-scaling clusters, which make it so you can scale your infrastructure based on demand, and load shedding protects your system if it can't scale fast enough. Redundancy with failover strategies. So for example, if one AWS region goes down because Oregon fell into the ocean, you can switch over to serve all your content from a backup region. Your error experiences have a big impact on how disruptive failures are to your user experience. Fault tolerance and isolation. This includes everything from basic exception handling to things like fallback strategies, and also circuit breakers, which is a design pattern I'm going to talk about at the end. And all the different types of testing, which are obviously super important for discovering issues, and making sure you don't introduce new ones. And then chaos engineering, which is when you run automated experiments that inject latency and failures into your system, usually in a small subset of your production traffic, to uncover issues before they start affecting all users at 3 a.m. on a Saturday. And that's just the beginning. I ran out of space for more bullet points. And unfortunately, I won't even have time to go super into depth on all of this. So I'll just be focusing on these because they're easy for us to make an impact on as JavaScript developers. I think for the most part, we can all recognize a bad error experience, but turning it into a good one isn't as simple as just showing a nicely written error message instead of your stack trace. Effective error messages provide as much context as possible. They not only tell you what went wrong, they also give you an actionable way to fix the problem. You've likely heard some UX guidance on things like form validation and handling errors that are a result of user input. But what about when we don't really know what happened? We just know that something blew up. This is our generic "we don't know what happened" error page. It's a little better than some of the ones we looked at earlier. I mean, at least it's pretty, and there's a number to call support. But if you call support, you might just get asked some questions about what browser you're using, and have you tried refreshing the page or clearing your cache and cookies, and it's probably not going to fix the problem. It's kind of like when you call Comcast and they tell you to turn your router off and on again, right? And the more people see this error page, the more call support is going to get, the longer they're going to wait on hold, the more mad they're going to get, and it's not really going to help things that much. So it's way better if you can give the users a way to fix the problems themselves. For example, if it's a 403 error, you can just give them a way to sign in. But there's different types of 403 errors. So for example, in our video player, sometimes they're getting a 403 because their subscription just isn't a high enough level to allow access to that type of content. So we differentiate and make sure that the button that they see is actually going to fix the problem for them. And this is our generic video error, but the try again button will actually cycle through a few different CDN URLs. So it may fix the problem if it's something specific to the video URL or a whitelisting issue. If there's a bad URL, obviously give them a 404 page with a link back to your home or search. And if you know your system's down, say that. Twitter updates are great too. When GitHub stopped working earlier this summer, it was awesome that I could just log into Twitter and see that it wasn't just me. I didn't need to really do anything except wait until it was back up again. And since I've been learning about this stuff, I've noticed some pretty sweet pages on sites like YouTube and Slack that have a lot of self-serve diagnostic options. So we kind of copied that idea and made a simple diagnostic page that would help rule out the most common problems we see, like incompatible browsers, corporate firewalls that don't have our CDNs whitelisted, stuff like that. And our support team loved it. So a fault is when something in your system is in an incorrect state. And a fault-tolerant system can handle some amount of faults without showing the users the error. But I want to start out with the isolation part, which involves eliminating things that could act as a single point of failure. A common example is identity APIs. At a previous job, I worked at a system one time where there's an identity API that basically just decoded a JOT and returned a user handle, and then all the other services and everything else in that system depended on that user handle to do anything. The benefits to doing it were that way was that there was no duplication of the JOT validation logic, but the trade-off is that all these other services had an extra network request, which first of all takes time, but more importantly, can take down the whole app at once if that service breaks because everything else depends on it. So that's why it's so important to avoid unnecessary integration points. Separating something into a separate service just for a minor improvement in developer productivity is almost never worth it. My team is maintaining a couple extra services. We had one that was just an abstraction around all the things we cache, and another one that was just an abstraction around listening to and publishing messages. And we were able to eliminate a ton of integration points just by getting rid of those services and putting the caching and messaging logic in the services that use them, and reducing like duplication just using a library. Another example is one time in a previous job, I had to talk a whole room full of people out of making an API that just returned all the static content on a page, so like an array of strings that represent paragraphs and fields for every button and heading on the page. And the only benefit to doing it that way would have been that they could write a ticket to have a database admin change the text instead of a front-end developer, which was hardly even a benefit. But the risk is that it takes longer for the page to load. And if there are any failures anywhere in that service, the whole page is no longer usable. I'm not saying that microservices or integration points are bad, just that we need to be careful to not make dozens of extra ones that don't provide much value and create a lot of extra risk. So one of the first steps on your path to better error experiences should be defensive programming. Null checking anything that could be null or undefined will help make sure your application doesn't throw errors when it doesn't really need to. This code's straight out of my slide 5. But we do this all the time. If you know that whatever you're going to do is not going to work, if you don't have the required input, fail early. It's a good idea to add some kind of model validation for your input at integration points. So if someone posts your API with a body that's different than what you're expecting, you should be able to detect that and return a 400. And if you know you don't have the data you need to make a request, just don't even try. it's also important that you have a way to monitor and understand your errors so you can fix them. And you can just make your functions throw exceptions and wrap calls to them and try catch blocks, or use maybe monads or either monads or something like that if you're into functional stuff. But you don't need to do these in every single function, but it's especially important at integration points, at the boundaries of your application, where it's more likely that you're going to have problems because you don't control everything. And there's a lot of different ways to manage the flow of errors throughout your application, and for the most part, they'll all work fine, as long as you're doing something and handling your errors and your exceptions are being caught and tracked. If you're not doing this already, it might be a good idea to add a top-level catch-all for any errors that may have made it through the rest of your application, because your error handler function can, in fact, throw an error itself. On the front end, you can use window.onError for this, and this is what it looks like in code. If you return true, it will stop the error from ever getting to the browser, which in certain older browsers can cause like that pop-up alert dialog with your stack trace. On the server, you can use process.on unhandled rejection for unhandled promise rejections, and process.on uncaught exception for other errors. And this way, you can get the stack trace and log it and actually figure out what you need to do to fix the problem. We normally talk about fallbacks in terms of servers going down, but I want to preface this section by saying that it also applies to CSS. That's what happens if that's why you put a whole list of fonts in the font family property, just to make sure that it falls back to something better than Times New Roman if your font fails to load. And what if your users are stuck using a browser like IE that doesn't support CSS variables? The first time I tested our most recent page in IE, it was, we were using a lot of CSS variables, so it was just like black text on a black screen, and I didn't even think that the page was rendering. It was completely unusable. So it's pretty easy to just add some polyfills to fix that. But if you don't do that and you don't like have some sort of error messaging that tells your users that they're using an unsupported browser, they're going to have no idea what's wrong. And setting up fallbacks that kick in when servers go down or timeout is probably one of the most impactful ways to improve your error experiences. With the microservices architectures that are super common these days, there are always tons of integration points. So you have to plan on an unreliable network. And accept that sometimes you'll be missing some data you need. And obviously, a great error experience is still really annoying. So it would be way better if you could just keep using the app like nothing was even wrong. On the back end, this can sometimes be as simple as hitting a database directly when your caching layers go down, because you can still get the data, it just won't be quite as fast. Or maybe there's a secondary service that provides some of the data you need, it's just not as complete. In other cases, you might be able to do without the data and keep the user from knowing that anything is wrong. If there's a service that tells you whether the user is an employee, so that you use that to like conditionally render some extra content on the page, it really shouldn't break your whole experience if that service goes down. You can just assume that no one's an employee and not show that content, and then the only people that will know that anything's broken are employees. And what if the API that says whether or not the user has a subscription goes down? This is the type of thing that you would want to talk over with your product team, but you might be able to just let users watch the content for free and pretend that everyone has a subscription. That's what Netflix does, and that's how we handle it on the video team at Pluralsight. Obviously, you need to monitor this and have alerts so that you know when it happens and the ops has visibility into it, but in most cases, it's much better to just let a couple of people watch some extra content for free until your API recovers than it would be to make the whole app unusable for all your subscribers. Sometimes you might not have another place to get the data, and you can't just pretend it isn't necessary, so you just have to degrade the experience a little bit. We have one API we use to get the course progress that you see here with, the little check marks over there. And if that goes down, we still have the check marks in local state, They just won't persist when you refresh the page. So worst case scenario, it looks like this. So that's not awesome, but it's not keeping anyone from using the app. Another example is these link components that we have for external labs. That data comes from an external API. It's kind of hard to see, but where the orange thing is, that's actually a different content type that creates this component that has a link that links directly to an external lab. And that data comes from a different API, and we merge it in with the rest of the table contents before we render the page. But if for some reason that service fails, we just leave a video that explains how to do it without the button, and nothing blows up. What about when you get an error posting to your analytics service, or if you use an event-driven architecture and you have an error publishing a message? That's probably not worth crashing your app over either, right? But sometimes that data is super important because you need it for calculating payments or recommendations or whatever, and it would be really bad if you just lost all that data for a while. So in this case, you can still fail silently as far as the user is concerned, and then retry processing them later once your system is healthy. And one of the best ways to build fault tolerance into your system is by wrapping calls that could fail or time out in circuit breakers. A circuit breaker detects the level of faults in calls placed through it and prevents new calls from executing after a configurable fault threshold is reached. This is the metaphor that circuit breakers and software design are based on. This is what a modern breaker box looks like, and your electrical main comes in through the panel at the top and then feeds the breakers, which distribute electricity to the different areas of your home. So if you're in the basement trying to run like a welder, a couple halogen lights, and your washer and dryer all at the same time off of one 15-amp breaker, that breaker's going to trip. But it's not a big deal because you can just unplug the welder, maybe plug it in somewhere else, and flip the breaker to your basement, and all your lights are back on, and you're all good. But back before fuses and circuit breakers were a thing, people's houses just caught on fire when they overloaded their electrical system. So this is obviously better. In software, a circuit breaker will guard a request, and if it knows that the other system is not happy, it will just skip the call. You can use them to wrap remote calls to an external system, or for internal calls that are subject to timeout or execution failure, like database operations. In the normal closed state, the circuit breaker will just let requests pass through like normal. But if a request fails or times out, the circuit breaker will keep track of that failure. And once a number of failures reaches whatever threshold you've set, the circuit breaker will trip and become open. And while the circuit breaker is open, it will just return a failure immediately without even trying to make the real request against the external system. Then after whatever time you've decided on, say 3,000 milliseconds, you decide that the next request has a better chance of succeeding, so you set your circuit state to half open and let another request go through to the other system. If it succeeds, the circuit state becomes closed and the subsequent requests get passed through normally again. And if it fails, the circuit state gets set back to open and it won't try another request until another timeout has elapsed. And that's just a state diagram. Now, these can obviously be made fancier, and you might want to handle timeouts differently than execution failures, but that's the basic idea. And you should definitely add logging and instrumentation that tells you when a circuit opens and how long it was open for, so you have visibility. One implementation detail you have to decide on is what constitutes too many failures. You're going to need to keep track of the density of failures in a certain time period, but that might vary based on how often the request usually happens. So, for example, maybe you say 5 failures and a 30-second time window means that the circuit should open. This pattern becomes even more powerful when you combine it with some of the other fallback strategies we talked about earlier, because when a circuit is opened, you still have to figure out what to do about the calls that come in. Maybe you just have to return a failure, but sometimes you can call a secondary service when the primary one isn't available, or return a cache value, or return a generic result instead of a personalized one. My team's implementation of circuit breakers is just a library that exposes a function that takes an array of functions to try, and the last one is usually a fallback function that just returns a generic result of some kind. But there's also lots of libraries for this on NPM. The most popular one is Breaks, which is based on Hystrix, a resiliency framework that was made by Netflix, and it lets you configure a timeout and a fallback function. So you can say, if we've had 50 timeouts in the last 10 seconds on an API call, continuing to pummel that service with retries is probably not going to help things and might even cause upstream cascading failures. So you can back off for a few seconds before trying it again to give it a better chance to recover. When it comes to fallback functions, this is an example of the fail open strategy we talked about earlier. So if we can't get the user's subscription info from the API we use for that, we just say everyone has access, and then we attach that meta tag so we can kind of tell if it failed open and maybe decide to handle things later on in the process differently. In this case, we decide not to post all the analytics and just enqueue those to pull down fresh data and retry once everything's good again. Here's another fail open example. There's a call we make against our cache to see what encodings we have for a clip so that we can accurately return a 404 instead of a broken CDN URL if someone is requesting an encoding that isn't available for some reason. But it's not really a big deal if that goes down, because we can just assume that all the encodings exist and totally skip that part. Most of the time, we're able to use some kind of fail open function like this as a fallback, but sometimes the fallback function doesn't do anything and it's just a no up. Michael Nygaard popularized the circuit breaker pattern in his book Release It, which is a really great book if you're interested in learning more about this stuff. And I think Nygaard summarized it best in his section on circuit breakers by saying, don't do it if it hurts. When there's difficulty with an integration point, stop calling it. And use this together with timeouts and fallbacks and make sure that you have a way to track your state changes. Resiliency is kind of one of those things where like your executives might not notice that nothing's burned down in a while and decide that that means everyone gets their full bonuses, because in most cases you're just making things less bad. But if you do it right, you'll sleep better. You'll get woken up by alerts at 4 a.m. less often. Your users won't be posting screenshots of your error messages on Reddit, and you'll be able to stay focused on cool new features instead of just putting out fires all the time. So when we write CSS, the cool way to do it is mobile first, right? So use min width instead of max width for your media queries, and don't add styles for columns and things like that until you actually need them. I remember back when that first became a thing, I had a little bit of trouble wrapping my head around how to do it that way, but there are some small performance benefits to writing your media queries mobile first, but it's not really a big deal whether you use min width or max width. The main point was just to not make responsive design an afterthought and bake it into our designs from the beginning. So what I'd like to encourage you to do is try writing your application logic sad path first. Think about what happens when the service you're getting that data from times out or returns an error. Move these discussions to the beginning of your design process and let fault tolerance be a driving factor in how you write code every day. There's the link to my slides. I don't think we have a lot of time left, but I'll be at the Pluralsight booth. We have a break after this if you have questions.
Thank you, Kristie.